In Chapter 10, we're going to talk about how to solve quadratic equations. Now, what's the difference between a linear equation and a quadratic equation? The quadratic equation has an exponent, x squared. So if you turn to page 698 and you look at the problems on 698, you're going to see something taken to the second power, x squared, so to speak. Or you're going to see a binomial like in number 24, x minus 3, that quantity squared. We're going to talk about how to solve these problems, and we're going to pick some fairly simple problems to begin with so that you understand the rationale behind the solution. Then we're going to pick some problems that are a little bit more challenging. So let's start with problem number 6. In problem number 6, what we have is x squared minus 13 equals 0. But what we want to do is we want to isolate that x squared by adding 13 to both sides. So we get x squared equals 13. Now, using the square root method to get x, we just take the square root of both sides. Square root of x squared equals the square root of 13. And so therefore x equals the square root of 13. However, because the square root of some number can be both positive and negative, we put in this symbol which looks like a plus with a little minus underneath. That means plus or minus the square root of 13. Okay? That's the basic rationale in solving these problems. Let's go ahead and take a look now at problem number 22. What we have in number 22 is 25x squared equals 13. I must like that number 13. I'm not sure why. 13 cards in a suit? Who knows? Here what we have to do is we take that 25x squared and divide by 25. So we have to divide the 13 divided by 25. Then we get x squared equals 13 over 25. Square root of x squared equals the square root of 13 over 25. But that's the same thing as saying the square root of 13 over the square root of 25. And the reason I do that is because now what I can say is x equals plus or minus the square root of 13 over 5, because the square root of 5 is just 5. Now, if you're a little confused about that plus or minus thing, let me just quickly explain that. We have the square root of 16, all right? If I multiply 4 times 4, I get 16. But the square root of 16 also holds if I multiply negative 4 times negative 4. Oops, put the negative in there properly. Negative 4. I also get 16. So when I get the square root of 16, that could either be 4 times 4, or it could be a negative 4 times a negative 4 gives me 16. That's why you end up with that symbol that looks like a plus with a minus underneath. All right? That's the rationale behind it. So no matter what's under the radical, it's going to be plus or minus that. Let's go ahead and look at number 30, and that's the reason why I did that sample. If we take the square root now of what's inside the parentheses, the square root of x plus 2, the quantity squared, equals the square root of 16. What we get is x plus 2 equals, the square root of 16 happens to be 4, but it's either plus 4 or minus 4. Can be either one of those. So when we solve that, if we take x plus 2 equals a positive 4 and subtract 2 from both sides, we get x equals 2. But if we take x plus 2 and it equals a negative 4 when we subtract 4 from both sides, subtract 2 from both sides. Let's do that properly. Subtracting 2 from both sides, we'll get x equals negative 6. So our answers for this were both 2 and 6. 2 and negative 6. Sorry about that. 2 and negative 6 were our answers. I picked number 30 for another reason. I want to go ahead and do this problem again. I'm not suggesting you do it this way, but let's go ahead and take a look at this. If, in fact, what we did was we squared that term on the left, what we would get is x squared plus 4x plus 4 equals 16. If we subtract 16 from both sides, what we end up with now is x squared plus 4x minus 12 equals 0. And in fact, we've had some problems like that in the past. If we can factor that trinomial x squared plus 4x minus 12, and yes, we can. What two numbers when multiplied together give me 12, the difference of which is 4? And I would end up with x plus 6 times x minus 2. And now if we go ahead and solve each one of those, x plus 6 equals 0, subtracting 6, we get x equals minus 6. And if we do x minus 2 equals 0, adding 2, we get x equals 2. Those answers are the same that we got when we did it the other way. So that's just one way of proving that using that using the square root method will get you the answers that you're looking for. Now we want to look at a couple that are a little bit more challenging. So we're going to take a look at problems 34 and 36. And I'm going to erase some of this right now, but we're going to scroll down so that we have just our problems there. Now, if we look at number 34, interestingly enough, on the right side, 25, we know is a perfect square. And when we look on the left, we see that 16 is also a perfect square. So there's two ways to do this. Probably what they're looking for you to do, though, is take this 16, my fault, sorry about that, 16 plus 2 quantity squared divided by 16 equals 25 divided by 16. Now what we get is the quantity x plus 2 squared equals 25 over 16. When we take the square root of that, over 16. What we'll get is x plus 2 is equal to either plus or minus 5 over 4. Now what we're going to do is let's go ahead and say if x plus 2 is equal to a positive 5 over 4 and we subtract 2 from both sides, we'll get x equals negative 2 plus 5 over 4. Common denominator being 4, that's the same thing as saying a negative 8 over 4 plus 5 over 4. And therefore x is equal to a negative 3/4. If we do the same thing, take x plus 2 equals a negative 5 over 4, and we subtract 2 from both sides, we'll get x equals negative 2 minus 5 over 4. Again, our common denominator being 4, we'll get negative 8 over 4 minus 5 over 4. Got nothing but negatives here, so when we combine that, we get x equals a negative 13 over 4, or x equals a negative 3 1/4. Okay? So we've solved, that's problem number 34. And now we want to take a look at number 36. So we're going to erase a little bit here. What we need to do with 36 is we need to manipulate the negative numbers. We need to get rid of those if we can. And using the same approach we used with number 34, what we're going to do is we're going to take this negative 5 times the quantity x plus 4 squared, and we're going to divide that by a negative 5. Therefore, we'll take a negative 10 and divide that by a negative 5. What we end up with now, x plus 4 quantity squared equals 2. Now, when we take the square root of both sides, we'll get x plus 4 equals plus or minus square root of 2. Then we subtract 4 from both sides, and our answer is written this way: negative 4 plus or minus the square root of 2. So there you have problem number 36, where we had to divide first by negative 5 in order to come up with the kind of equation that we can work with using the square root method. I want to do one more thing, and that is take a look at problem number 50. Problem number 50 happens to be a story problem, and all I'm going to do is set this up. You can solve it once it's set up. But it says the square of the sum of a number and 5 is 36. So a number, we'll call that x, and 5, the square of that is 36. So that's problem number 50 as you set it up. Now, of course, when you take the square root, x plus 5 squared equals the square root of 36. You'll get x plus 5 equals plus or minus 6. So in your answers, when you subtract 5 from both sides, you're going to get either x equals 6 minus 5, which is 1, or x is going to be equal to negative 6 minus 5, which is a negative 11. So there you have it, using the square root method for solving quadratic equations.